And double check. Okay. Hello, everyone. It's time for us to present. Our group name is Sixers, and we are ready to prepare our laboratory activity number 2. This is for diodes regarding the forward and reverse bias of a circuit. To start, let's go directly to part 1. On the on the image here, we have a diode and LED resistor with a 9 volt power supply. Here is our picture regarding the image here. Here we place the corresponding wires to their positive and negative inputs. Put the right wiring components such as the resistor, the 1N4001 diode, a yellow LED, another wire, and just connecting the power supply to the breadboard itself. Now let's answer the questions. Apply the given circuit schematics in a breadboard and answer the following question. 1.1, is the LED light illuminating? Yes, it is illuminating because the natural flow of electricity isn't being interrupted by any components. Number 2, how come? As I've explained, current is moving freely on this circuit, allowing proper components to run. And I think that's called forward bias. And let's go to 1.3. What type of bias is the diode in the figure? The orientation of the diode is at forward bias, allowing the LED to light up. Number 2, change the polarity of the power source and answer the following questions. Number 2 is demanding power source. Yes. We just flip the power source. So the red, instead of it being on the positive side, it was on the negative. And the black, it should be on the negative, but we put it on the positive. Since there's not a natural flow of electricity due to reverse bias, electricity cannot flow to the proper components and the LED won't light up. That's the brief answer. How come? As I've explained, due to incorrect polarity of the wirings, the LED wasn't able to light up because there wasn't a natural flow of electricity or current. What type of bias is the diode in the figure? In this figure, it showed forward bias because of, if we see where the positive flow of electricity goes and how the image of the components is, we can deduct what is the position of the component. And as we can see here, the diode its image is pointing downward, indicating a forward bias flow of electricity. Okay, let's go to part 2. Part 2, in this case, we're setting up a electric circuit based on this image. And by following these instructions, let's continue. Here is our graph showing all of the voltage inputs of the forward bias. This graph shows forward bias. And this table. And this table shows the reverse bias of the circuit. Okay, let's start with 1N4001. Since our professor said that we only need to put one picture per diode, or in our case, we did 4 pictures, picturing the voltage input, anode to cathode voltage, anode to cathode current, and then showing the diode. No, not the diode. Wait, it is a diode. All right, let's proceed with 1N401. In our voltage input, we got 0.517 volts, which is the closest we can get to the original being zero point 0.5 volts. To double check, let's get the image below. Oh no, this is the power supply. Ah yes, this is the voltage input. Here we use a multimeter to check whether it is right. To confirm, this is 0.507 volts. And looking at the circuitry, it looks correct. And let's go for anode to cathode voltage. Oh, by the way, this is the image of the power supply, indicating that we followed the instructions of 5 volts in the forward bias case. The reverse bias I will be showing later on in this video, but let's continue. Let's check for the anode to cathode voltage. Here it said negative 0.522 volts. Let's double check. Yes, here it is. It may not look like a negative, but in this, there is a dash that you can see here showing a negative 0.522 volts. Is it correct? It is correct. Okay. Confirming that, let's continue with the anode to cathode voltage and voltage current. Here is our first challenge that we encountered in this graph. As you can see, every anode to cathode current, forward bias or reverse bias, it all showed 0.000 amperes. We do not know why this is the case, but we just put it here as a reminder. And wait, we have an explanation later in the conclusion. All right. Since every single table of every diode, forward or reverse bias shows 0.00 amperes, I'm going to show you only one picture of it. Here's the reading. Yeah, here's a reading on the multimeter. And for as a reminder, this is direct current. It's the picture is just not showing it, but I can confirm that it is direct current set on the multimeter. Here it is, 0.000 amperes, and that is correct. And let's proceed to the other diode. Oh, no, not the diode. Let's proceed only to the reverse bias for now. So we will do 1N4001 forward bias, negative bias, and the rest will show that line. Alright, for the reverse bias of this diode. Again, let's check its voltage input at 0.510 volts. Originally, we were supposed to get as close to 0.5 volts, but this is as close as we can get. And let's double check. And reminder, this video has a lot of scrolling. Here it is to check on the voltage input, and the diode here is showing reverse bias since we flipped it. Here, 0.510 volts. All right. It is confirmed this is the Alright, now let's check its anode to cathode voltage. It should be negative 0.502 volts. Here it is. Negative 0.522 volts for its reading. All right. This is to confirm it. Now let's proceed. Time for the anode to cathode current. Again, it is showing 0.000 amperes. Let's confirm it. Here it is. 0.000 ampere reading by the multimeter. Okay, let's proceed to 1N4148 diode. And now we'll go back to forward bias. All right, we are indicating the correct amount of voltage. Since I can't put it on exactly 9 volts, I just set it as close to 9 volts as possible. So in our case, it was 9.17 volts. And now let's check for its voltage input by confirming what I've said earlier. We set it as 0.510 volts, showed by the multimeter, indicating that in the table it is correct. Let's now proceed to the voltage reading. On the table, it must show negative 0.502 volts. Here's a correct circuitry. Now let's go scroll back, double check. Here it is. Wait, what did I check? Voltage reading. Yes, for the voltage reading, it was this case. I aligned it on our voltage input, but again, it is difficult to align it perfectly with our previous reading, so I just did it as close as possible. So it showed earlier 502, and now it's this 0.17. Now let's go for the anode to cathode voltage. Here it is. Now this is the voltage input. And this is the voltage in reading. All right, this appeared to be correct. And again, for the voltage current reading, it showed 0.00 amps. As I've said earlier, that all of our readings, when it comes to the ampere, showed 0.000 amps. So I will not be repeating anymore, since in this video I've already implied many times that it is constantly 0.000 amperes. Okay. Here's showing the power supply at 1.16 volts, as close as 5 volts as possible. For the voltage input, 5.520 volts. Let's double check. Here it is. Voltage input, correct? Yes. It is as close as possible. Okay, voltage reading. Here it showed negative 0.510 volts. Let's check it on the table. Here it is. Being our reading is correct. And here is the reading for the current bias again. And it's time for the reverse bias. As per the instructions, we set it as close as possible to 9 volts. Here the reading being 9.18 volts. Here's our voltage input for the reverse bias. Please take note that in one of these pictures, we only included the pictures ranging from 0.5 volts. We didn't put every single picture of every single voltage input because that would be too many pictures. So I only started with the lowest voltage required at 0.5 volts. Here it said 0.508 volts. Let's confirm it in the table. Reverse bias. Yep, went as close as possible to each voltage input. Now let's go check to the voltage reading. Here it is, negative 0.496 volts. Let's double check the table. Here it is. So our reading on the multimeter is correct. Now, last but not the least, let's go to the last dial, 1N60. Let's go first. Since it is a forward bias, let's go and check it out. Here it is. In this case, I got lucky and I managed to match it at exactly 5 volts, matching the requirement needed for the forward bias. Voltage input, yes. Unfortunately, this was as close as possible to the required input of 0.5 volts to begin. But in this case, we only got 0.380 volts. Now, let's go for the first voltage reading. In the multimeter, it showed negative 0.219 volts. Let's double check on the table. Here it is. The reading on the multimeter is correct. Now let's go for current reading. Here it is, showing again 0.00 amperes. And let's go for reverse bias this time. Power supply at 0.903 volts. Since the picture was unclear because of the wire here, you just gotta believe me that this is 10 volts. Alright, voltage input as close as possible to 0.5 volts. Our reading showed 0.508 volts. And for the voltage reading, in this case it showed negative 0.510 volts. Let's double check it on the table. Here it is, correct. And that will be all for this table. And we will now continue for the pictures. Oh, in this case, I did not attach a photo here since most of the pictures are already below a few more pages. So I don't need to put any pictures there. It will just add extra space. Just take note. And here I will conclude my part of this video because my group mates will now handle the guide questions. All right.
So for guide question, First, what did you observe about the electrical behavior of the different diodes? We observed that the different diodes exhibited distinct electrical characteristics in terms of their forward voltage drop and current response. Although all diodes allow current to flow under forward bias and block current under reverse bias, the amount of voltage requires the conduction. Especially, the 1 in 60 diode requires a lower forward voltage to conduct compared to the 1N4001 and 1N4148 diodes. This difference is mainly due to the type of conductor material used. The 1N60 is a germanium diode, while the 1N4001 and 1N4148 are silicon diodes, which generally have higher forward voltage requirements.
So for the question number 2, what caused the diode to operate in forward and reverse bias? So ang nakapag-cause ng diode to operate in forward and reverse bias is mainly depends on the orientation and polarity of the connection. So kapag nakakonect yung anode sa positive terminal ng power supply at yung cathode naman nasa negative, ibig sabihin nakakapag-operate yung diode na in forward bias. And in our setup naman, nilagay namin yung anode sa left side connected to the resistor, and then yung cathode is nasa right side. Because of that proper alignment, mas nakapag-flow yung current through the diode ng maayos. And on the other hand naman, para ma-achieve yung reverse bias, we simply flip the diode. Meaning, yung cathode ang nakakonect dun sa positive and yung anode naman is nasa negative side. Since baliktad na yung polarity ng diode terminals, na-block na yung current flow. So in short, ang dahilan kung ba't nagiging forward and reverse bias yung diode is dahil sa polarity ng power source and orientation ng diode sa mismong circuit or breadboard. And for the next question, compare the forward voltage drop of 1N4001, 1N4148, and 1N60. What differences did you observe? So, based sa observation na ginawa namin dun sa experiment, ang 1N4001 has a forward voltage drop of 0.66 to 0.67 volts. And yung 1N4148 is almost the same lang and around 0.67 to 0.68 volts. Pero yung 1N60 is much lower and nasa around 0.22 to 0.41 volts lang siya. So, ang difference na noticeable sa tatlong diodes is that the 1N60 conducts at much lower voltage compared to the other two. This is because the 1N4001 and 1N4148 is silicon diodes, which typically requires around 0.7 volts to turn on. And meanwhile, the 1N60 is germanium diode. And yung germanium diode is natural sa kanya na may lower forward voltage drop siya. So, mas madaling mag-conduct yung 1N60 kahit mababa lang yung applied voltage.
So, for number 4, why is the reverse current very small compared to the forward current? The reverse current is very small compared to the forward current because when the diode is under reverse bias, under depletion region winds, as a result, the movement of majority charge carried is black, preventing significant current flow through the diode. So, during the experiment, When we measure the revised current using a multimeter, the reading was approximately 0.00 ampere. This indicates that only very minimal leakage current exists under revised bias condition, which is too small to be detected by the measuring instrument. Therefore, compared to the forward current where current flow normally, the reverse current is almost negligible.
So for the last question, how do the V1 characteristic curves helps in understanding diode applications in electronic circuits? So yung V1 curve is nakakatulong sa atin para ma-visualize yung diode's behaviors under different voltage conditions. Una dito is yung turn-on voltage. Ang turn-on voltage kasi meaning kung kailan lang magsisimulang mag-conduct yung diode. And yung sumunod dun is yung forward voltage drop. Ito naman is yung when yung current is nagsimula na siyang mag-flow sa circuit. And third is yung reverse blocking region. Pinapakita din ng V1 characteristic to. Where the diodes is pinaprevent niya yung current from flowing. And because of this curve, mas madali nating ma-determine kung saan best gamitin yung specific na diode. Ang best example dito is the 1N4001 is commonly used for rectification in power supplies. And yung 1N4148 naman is ginagamit to sa high-speed switching applications. Pero since mas mababa yung forward voltage ng 1N60, yun lang yung ideal for low voltage detection circuits. So overall, yung V1 curves is nakakatulong sa atin para maintindihan kung paano gumagana yung diodes and kung saan siya pinaka-effective gamitin sa totoong electronic circuits.
There are parts of the part 2 table that we have encountered problems, such as in the forward bias part, we have incorrect readings by the multimeter that the output should be positive, but the output showed negative. Yes, that was the case that happened. Let's check the table. Here are examples. Here, all of their readings are either negative for the 1N401, 1N4148 diode. It also showed negative outputs, and even the 1N60, it also showed negative outputs. Even though in our circuitry, the parts, the components, everything was right, but our readings still showed the negative. Here, you just noted it here, so that it will be here when our professor checks it. And as for the reading of the current, we tested all of the diodes and all this still showed the same reading at 0.008 amperes. We also did not, and as I said earlier, we didn't include any pictures for the amperes since it would just be too many and impractical. It would just show up so many pictures, soaking up more space, increasing the file. And I will conclude in that video. Okay. I will now conclude the video. Thank you so much for listening, and thank you.